Let's go into what kind of. So we saw the NLP applications where they are getting used day to day, and where AI is really helpful to us. But while using them, we'll always check for. We'll need to evaluate them, and we'll need to say yes, this is correct, and we need more of the metric. So there are certain ML metrics for classification, which is a supervised machine learning. For regression also we have certain metrics, and also we were talking about machine translation and summarization. They also have certain metrics. So most of us would have seen when we are working with applications for sentiment analysis or any use case that relates to classification, we would have seen that we are using accuracy. Accuracy is basically what how much is correct out of the total number of instances. Whereas we sometimes need to give a weighting scale between precision and recall. So what happens is, precision is basically the ratio of correctly predicted positive observation to the total predicted positives. So what happens is, sometimes we need more weightage to precision, sometimes we need more weightage to recall. So based on the business scenario and our current current scenario that we are working in, we need to choose whether we need precision or we need recall. And sometimes in enterprise use cases, what happens is the team will directly go for F1 score. Okay, we need a weighted average of both precision and recall. I am not going to use simple metrics like accuracy. I'm not going to give weightage to any one of precision or recall. Now what I'm going to do is, I want to give a weighted average to both precision and recall. So that is when F1 score comes into play, and it's really tough to get a very good F1 score. We need to do multiple iterations of creating models and trying out multiple things as experiments to get a very good F1 score. And the other metrics are ROC underscore AOC and log loss. So let us go to regression metrics, where okay, for example, there we took an example of sentiment analysis. Here in regression we can take an example of either sales forecasting or demand forecasting. So what happens is, okay, the metrics that we are seeing here are just some of them. Mean absolute error, mean squared error, root mean squared error, R squared, mean bias deviation. So these are all metrics that depends on either the absolute errors or the squared errors, or which is a square root of the average of these predicted and actual values. So what happens is, we need to be very careful in choosing these metrics. We can go into enterprise projects, work for any number of projects, but what really matters is to choose the right metric for each and every given scenario. It can be two teams can be working on the same project, same use case, but based on the data that they have, they need to assess whether we are going to use the right metric or not. One team could be using accuracy, the other one could be using F1 score. But what happens is, the team using accuracy may not be going the right direction, whereas the team that is using F1 score could be going the right direction, because that is what is needed in that specific scenario, in that business use case. So that is why we need to understand business first, then apply AI or ML to any of the enterprise projects. Okay, let me go to certain NLP metrics. So we were seeing about supervised machine learning metrics, which are dependent on, for the classification and regression. Now we will see NLP metrics for translation summarization. So one of the one of the research papers that we were working at my previous organization, we were doing text and document summarization. There we were using both RAUG and blue scores. What happens is, so for blue score is nothing but we are evaluating for a general sentence, but we also have something called a reference sentence. So based on the reference sentence, we are seeing whether the generated sentence is close to that reference sentence. That is what humans will do, right? That's how we can we get to know, okay, this translation is done. We'll check in Google Translate, okay, this translation is close, yes, this is good, and that is the same mechanism that blue score is trying to use. But in rogue score, what happens is, it has certain minor level metrics inside of it that will determine that will try to determine and evaluate these automatic summarization, and also it can be used for machine translation. And perplexity, what happens is how probable that predicted value is going to occur. So perplexity is used very rarely, but I mean, if you are having a niche use case like text generation that is being used widely in the system, then only perplexity comes into play.